Hello everyone, this is Shri Guru over here. Welcome back to my YouTube channel. In the previous class, we have started a semiconductor. In that, we have studied a band theory of solids, and based on that, we have divided the materials into three groups: insulator, semiconductor, and conductors. As you know that conduction band is like this, and a semiconductor band is like this, and insulator band is like this. Look at the some properties of conductor, insulator, and semiconductors. Look at the first property. Electrical conductivity of the conductor is in the order of 10 raised to 2 to 10 raised to 8 mho per meter. Mho, it is a reciprocal of ohm. Similarly, for insulator, it is in the order of 10 raised to minus 11 to 10 raised to minus 19 per ohm per meter. You can also say that it is per ohm. In case of semiconductor, it is in the order of 10 raised to 5 to 10 raised to minus 6 per ohm per meter. Next property of these materials is resistivity. Resistivity is a reciprocal of electrical conductivity, and therefore the order is get changed exactly reverse as we have studied in the electrical conductivity. For the conductor, it is 10 raised to minus 2 to 10 raised to minus 8 ohm meter. For insulator, it is a 10 raised to 11 to 10 raised to 19 ohm meter. And for semiconductor, it is 10 raised to minus 5 to 10 raised to 6 ohm meter. And these band structures already we have studied in the previous class. In case of semiconductor, there is a overlap of conduction and valence band. Either they overlap or there is a zero gap. For insulator, there is a large gap, and that gap is measured in terms of electron volt, and it is known as a energy band gap. And for semiconductor, the energy gap is very small. Energy gap, as you can see here in the next, energy gap is either zero or it is a very small. And for insulator, it is greater than 3 electron volt. For a diamond, it is a 6 electron volt. It is very large. And for semiconductor, it is less than 3 electron volt. In case of conductors, the charge carriers are free electrons. But in case of insulators, there is no charge carriers. But in case of semiconductors, the charge carriers are either electrons or holes. The next property, the conduction band and valence band at the ordinary temperature. At ordinary temperature, valence band and conduction band are completely filled, or the conduction band is somewhat empty. There may be a somewhat empty is there in case of a conduction band. But in case of insulator, valence band is completely filled and conduction band is completely unfilled. And similarly for the semiconductors, the valence band is somewhat empty and the conduction band is somewhat filled. Temperature coefficient for the conductor, it is a positive. You can study this temperature coefficient in the current electricity chapter. That is, it is represented by alpha. And for insulator, temperature coefficient alpha is 0. For semiconductor, it is negative. What are the effects of temperature on these materials? Look at the first one, effect of temperature on the conductivity. For the conductor, as the temperature increases, conductivity decreases. And next, for the insulator, it does not affect of the conductivity. It remains unchanged. In case of semiconductor, as we go on increase the temperature of the semiconductor, conductivity also increases. How? We will discuss in the next class. Look at the next property, electron density. Electron density for in case of conductors 10 raised to 29 per meter cube, and insulator we don't need to study this. Look at the next one. For germanium, it is a semiconductor. Electron density is 10 raised to 19 per meter cube. For silicon, it is 10 raised to 16 per meter cube. And examples for the conductor are given here. And for insulator, it is wood, plastic, mica, diamond, glass, etc. And for semiconductor, germanium, silicon, gallium, arsenic, etc. These are the examples for semiconductor. We have to remember all these numbers when we are solving the problem. Thank you for watching my video. Don't forget to like and share and subscribe.